Okay, I think we're going to go ahead and get started. Expect a few more folks to join us as we progress. I'd like to welcome all of you to AISI's third annual environmental briefing here on Capitol Hill. I'm Andy Sharkey, President and CEO of the American Iron and Steel Institute. Our members are responsible for over 75% of the steel that's made in North America and here in the United States. As an industry, we are fully committed to building a more sustainable world for future generations. The evidence of this commitment is seen in the continued lightening of our industry's environmental footprint. We are a very energy-intensive industry, and over the past decade, American steelmakers have reduced the energy required to produce a ton of steel by 29%. More steel is recycled each year than all other materials combined. Even water, an important coolant in the steelmaking process, leaves the plant cleaner through extensive filtering than when it entered the mill. In terms of climate change policy, the American steel industry is part of the solution in this debate, not part of the problem. Due to our tremendous gains in energy efficiency, we have achieved a related 16% reduction in greenhouse gas emissions, largely through recycling and investments in new technology, again since 1990. 3/4 of all American steel ends up recycled into new products, which is part of our industry's comprehensive environmental commitment. The global problem of climate change can only be addressed effectively on a global basis. This means that domestic producers and importers should have to meet the same high standard in order to sell in the U.S. market. Related to this approach, we support the idea of carbon intensity standards that set an upper limit on greenhouse gas emissions per ton of steel produced, and that apply to all steel consumed in the United States, whether domestically produced or imported. We appreciate you taking time to attend today's briefing. We're committed to working with all of you, members of Congress, staff, as well as representatives for the federal agencies, to provide accurate and timely information. At the conclusion of our special guest speakers' comments, we will be happy to entertain any questions that you have. Joining me to help field any questions specific to AISI and our industry's environmental report card is Larry Cavanaugh, who's AISI Vice President for Manufacturing and Technology. At this time, I'd like to introduce Dr. H.Y. Sohn, Professor, Metallurgical Engineering and Chemical Engineering at the University of Utah. Dr. Sohn is working on important research that offers tremendous value to the steel industry and to the environment. The research is part of the CO2 Breakthrough Program, an international voluntary effort among steelmakers worldwide, aimed at uncovering ways to make steel with little or no carbon emissions. And AISI is actively engaged in supporting this innovative program. Professor Sohn received his Bachelor of Science degree in 1962 from Seoul National University and his PhD in 1970 from the University of California at Berkeley. Dr. Sohn joined the Department of Metallurgical Engineering at the University of Utah in 1974 and currently holds the rank of Professor of Metallurgical Engineering and Adjunct Professor of Chemical and Fuels Engineering. Dr. Sohn's work has been recognized through numerous awards, which include the 2001 James Douglas Gold Medal Award for Leadership and outstanding contributions in metallurgy research and education. He's also an internationally recognized lecturer and author. Following Dr. Sohn's comments, the three of us will be happy to respond to any questions that you might have. Dr. Sohn? Sir.
Thank you, Andy, for the nice introduction. And you gave away a secret about my age when you said I started at Utah in 1974.
Sorry about that.
I'd like to thank AISI for having me at this briefing, and I'd like to thank all of you for being here, listening to some of the issues that are very, very important in our modern lives. This particular talk is about a novel iron-making technology that we are developing, and it is being done at the University of Utah. There are two places I can look at. Again, my name is H.Y. Sohn, and the project started with the DOE carbon dioxide breakthrough program about 2.5 years ago. And although that's not an official phase 1, we like to call it unofficially phase 1. Phase 2, the contract has been just signed, so it will start very soon. And that is funded entirely by AISI and its member companies, and the list of companies include the largest steel companies in this country and indeed in the world. And I am very grateful that these companies are certainly from the point of view of supporting my research, but also aside from that, the companies are trying to put their resources in trying to solve the important problems, especially carbon dioxide emission and the energy reduction in steel industry. And as we all know, carbon dioxide emission is everybody's problem. It's not just steel industry problem. It's not just one industry. It just is a problem that every one of us must be concerned with. And in that regards, I hope the government, this is a seat of the government, and I hope that the government puts a lot more resources in research of this type to solve very serious problems. Okay, the overall objective of this project is to develop a new novel iron-making process with significant reduction in energy consumption and carbon dioxide generation, as I said earlier. And the technology is based on hydrogen. However, the process does not depend entirely on hydrogen. It could run on natural gas, again with the substantial reduction in energy, as well as carbon dioxide emission. The process could even run on coal. Coal has a lot of hydrogen, so if we use coal, we can still reduce carbon dioxide emission substantially. The process also has an aspect of using fine iron ore concentrate without making coke, and without having to pelletize these fine iron oxide particles that we generate in large quantities in this country. About up to 70% of new iron produced in this country is based on that fine iron ore concentrate. So in terms of background, as we all know, steel industry is one of the largest industries of very, very great national and as well as international importance. And the current iron-making technology is mainly depend on the use of blast furnace technology. Blast furnace is the largest chemical and metallurgical reactor. As you heard that at the University of Utah, I teach metallurgical engineering as well as chemical engineering. So I know that it's the largest reactor in this area. I show you a schematic of the process. The blast furnace is the one in the middle with nice, bright, hot molten materials going through. The charge is made from the top, and the hot oxygen-containing gas is blown from the bottom, and the oxygen burns part of the carbon to generate heat. These things operate at very high temperature, up to 1500 degrees Celsius or so. And as I said, it's a very large reactor. Largest of the modern blast furnaces are 30 feet in diameter, up to, I say, 80 feet, but some of them, I believe, even reaches 100 feet of height. And think about this. The modern blast furnace produces, I said again 10,000, that's conservative. Some blast furnaces produce up to 1,000 tons of iron per day, 15,000